Hello, in this video, we're going to learn how the transformation of functions work. So the first transformation is we are going to change how the function looks like narrower, wider, or shift it to left, right, up or down, something like that. Okay. So the first kind of transformation of a function is translation. And simply translation is to shift the function to the left, right, or up or down. Okay. So let's say the function f of x here is x squared. Okay, which is the blue parabola where the vertex is at 0, 0, the origin. Okay. So this blue parabola is where f of x is x squared. Okay. So now the function has shifted to the left by 2 units, right? It shifted to left by 2 units. As you can see now, our new vertex is at negative 2, 0 because it shifted to the left by 2 units. Then, okay, then how do we change the equation to describe this? Okay, so when the function shifts to the left, we say y is, in this case, x plus 2 squared. Okay, so it is kind of easy to confirm if we actually plug in some numbers and what happens. So for example, in this new equation I suggest, if you plug in x is negative 2, then y will be negative 2 plus 2, 0 squared. So as you can see, when x is negative 2, now y is 0. Okay, and you can actually try more numbers and see actually it has shifted to the left. So one interesting or kind of annoying thing is I add 2 to shift the graph to the left side. So usually it's kind of counterintuitive because when you think about the left side of the y-axis, because the x values are negative, we think it's related to negative numbers, right? But we add 2 to shift the graph to the left by 2. So if we add 5, then so for example x plus 5 squared, then the graph will shift to the left by 5 units. Okay, then it's kind of easy to guess that how to shift the graph to the right then, right? So if this y is x squared, if I want to shift this to the right by 4 units, let's say, so something like this. Okay, so something like this. If I want to shift this graph to the right by 4 units, then what should I do? Then that's gonna be y is x minus 4 squared. Okay, so we subtract 4 from x to shift the graph to the right. Okay, so now you learned if you subtract a number from x, then the graph shifts to the right. If you add a number to x, then the graph shifts to the left. And again, another thing that can be confusing is then what is the difference between x squared, let's say minus 2, and x minus 2 squared. Okay, so I said in this case where the graph shifted to the left, I said that's this case, right? X minus 2 squared. So inside of this square, I subtracted 2. So if you look at the next example, so this is where y is x squared minus 2. Okay, so if you subtract 2, not directly to x, okay, if it's from entire function, which is not exactly the correct way to say, but that's easier to understand. So if you, let's say you have a y is x squared. Okay, if you have a y is x squared, to this entire equation you imagine you subtract 2, then what happens is it shifts down. Okay, it shifts down like this graph. So this blue one is y is x squared, and the green one is y is x squared minus 2. So as you can see, the graph has shifted down by 2 units when I subtracted 2 from x squared, not x. Okay, so this time it's not counterintuitive because I subtracted 2 and the graph actually shifted down. So now you can imagine if you want to shift this graph up by 4 units, let's say something like this, right? So if you want to shift the graph up by 4 units, then what should we do? This time we just need to add y is x squared plus 4, okay? Plus 4. Then the graph shifts up by 4 units. So as a summary, if you subtract a number from x, it shifts to the right. If you add a number to x, it shifts to the left. If you add a number to entire right hand side, then it shifts up. If you subtract a number from right hand side of equation, then it shifts down. So I don't want to go too deep about the notation, but for example, let's say f of x is absolute value of x, okay? So if I, how does it look like? That looks like this V shape, right? Kind of. So if you want to shift this to the right by 5 units, then what should we do? We need to subtract 5 from x, right? From x, which means it's not going to be absolute value of x minus 5. It's going to be absolute value of x minus 5 and close absolute value, okay? Then that will represent shifting the graph to the right by 5 units. Okay, again once more. If we have f of x is absolute value of x, or y is absolute value of x, let's say I want to shift this down by 2 units and left by 3 units this time, okay? So we are going to do 2 things at once. So we are going to shift it down by 2 units and left by 3 units. So eventually it's going to look like this. Then what should we do? So first, down by 2 will do. We need to subtract 2 to the entire right hand side, right? And shift it to the left by 3 units will be adding 3 to x. So it's going to be absolute value of x plus 3 and subtract 2 will be the last form of the equation. Okay? So next, let's go to the next transformation. So next one is stretch and compression. So again, the blue one is f of x is x squared, okay? And the green one is, let's call it g of x. So g of x is 2x squared. So as you can see, the difference is compared to f of x, I multiplied the 2 to the function, right? To the function f, I multiplied it by 2. So when I multiplied it by 2, the function became narrower, right? Or steep, or we call this vertical stretch, okay? Vertical stretch. So kind of making the function narrower or more steep, like increasing or decreasing more drastically. That's called a stretch, okay? Stretch. So this is called vertical stretch. Okay? So vertical stretch happens when the number you multiplied is greater than 1. Okay? When the number is greater than 1, then the vertical stretch happens. Then what if you want to make your function wider, like something like this time, okay? Then what should I do? Then you need to multiply a number less than 1, okay? But we are only, at this point, we are only talking about positive numbers, so less than 1 and greater than 0 technically. So for example, so in this case, when x is 4, y is 2, right? So let's say I multiply 1 over 8 to x squared, okay? To x squared. And I'm gonna call it h of x. So if x is 4, what is y then? If x is 4, y is 4 squared times 1 over 8. 4 squared is 16, and 16 times 1 over 8 is 2. So this graph h of x, you know, it's kind of a rough, not a good estimation, but anyways, is actually represented by this function h of x is 1 over 8 x squared. And as you can see, 1 over 8 x squared is wider than the function f of x is x squared. And in this case, we call this vertical compression, okay? Vertical compression. again, vertical compression happens when the number you multiplied to in front of the function is less than 1 and greater than 0. It happens. Okay. So next one is reflection. So reflection is, it's kind of how I explain usually is it's kind of folding the paper. So when you are young in elementary school or kindergarten, probably you did something like for the half of the paper you use ink to draw something, and you fold your paper and open it again. Then now the ink or the picture you draw is kind of copied on both sides, right? So now we are not copying on both sides, we're actually moving it, but that's how I usually explain what reflection is. So in this case, this blue function is f of x is x squared. And the green one is, let's call g of x, is negative x squared. So in this case, this is reflection over x-axis, obviously. And as you can see, I multiplied negative 1. Okay. If you see the next case here, when f of x is x squared plus 5x, which is this blue graph, if you multiply negative 1 to this function, let's say g of x is negative x squared minus 5x. Okay. Oh, sorry, not negative x plus 5. Sorry about that. G of x is negative x squared plus 5 times negative x. So what I'm doing is I'm changing all the x's or substituting x's with negative x, okay? Then what will this be? This will be x squared minus 5x, and that's going to be reflection over y-axis, okay? So let's go back to here. So if I multiply the entire function f of x is x squared by negative 1, so I made it negative x squared, right? Then what happened was reflection over y-axis, x-axis, okay? X-axis. As you can see, this is the x-axis. So if I multiply negative to the function, to the entire function, then it becomes reflection over x-axis. Let's go down here. And instead of multiplying negative to the entire function, this time I just swapped all the x's to negative x, okay? So f of x is x squared plus 5x, which is represented by this blue parabola, blue graph. And if I change all the x's to negative x, then you will get the g of x here, right? Which is negative x squared plus 5 times negative x. As you can see, compare these two. The only thing I did is I changed all the x's to negative x, okay? Then, what is negative x squared? So negative times negative is positive, so this is going to be positive x squared. Then what is negative x times 5 next? Negative times positive is negative, so this is going to be minus 5x. And if you graph this, that's going to be this purple parabola or the purple graph. And as you can see, that is reflection over y-axis, okay? Y-axis. So, if I summarize this, when you have function f of x, if you want to reflect this over x-axis, then that becomes negative f of x, okay? So if the function looks like originally this, after negative f of x, it's gonna look like this, okay? Let's say the function g of x looks like this time, okay? And if you want to reflect this over y-axis, then what you need to do is you switch x to negative x. Then it's gonna be a reflection over y-axis. Okay? So now, since we learned the reflection, we can talk more about compression and stretch a little bit more, okay? So I said about stretch, I said when the number you apply to function is greater than 1. So let's go back to there actually. So here, I say when the number you multiply to the function is greater than 1, that's going to be stretch, right? But what if the number in front of the function or the leading term is negative already, okay? So let's say f of x is negative x squared. Then it looks like this first of all, okay? So let's change the color. And what if I make g of x, which is negative 2x squared? Then technically negative 2 is less than negative 1, right? Because negative 2 is more negative than negative 1. So that's a smaller, less number, okay? But still the graph becomes narrower. And we are going to call that vertical stretch, okay? That's vertical stretch. So when I say it's a vertical stretch, and when I say that the number is greater than 1, it's not in the sense that the actual number is greater than 1. So technically that means when I say when the absolute value of that number is greater than 1, okay? So if the function is already negative, like negative x squared, so if you make it negative 2x squared, I know that negative 1 is greater than negative 2, but you just ignore the signs and just look at the number part, okay? Don't look at the signs, just look at the numbers. So it's 1 here and 2 here, and 2 is greater, right? So it must be narrower, okay? So what if I make h of x is negative half x squared? Then again, you ignore the signs. That's half compared to 1. Half is less, right? So it must be wider. Therefore, this is vertical compression, okay? It's vertical compression. Okay, so this time we reviewed function transformation. So if anything is confusing, please do the homework, and it's I'm pretty sure everything will be very clear once you finish your homework. Okay, so thanks for watching. See you next time.